So this is lesson 43 in Algebra 2, sine, cosine, and tangent, as well as inverse functions. Alright, so you are going to learn an old Native American name, SOHCAHTOA. This will really help you not only in this class, but if you continue on into college trigonometry, because this is one of your beginning stages of trigonometry. You've already done some back in pre-algebra, I think it was. But we're talking about triangles and ratios. So for instance, if we have this angle here, and we'll call it angle A, and we know that this is 3 long, and that's 4 long, we can figure out angle A's measurement. We can figure out this measurement, and we know we're going to make this a 90-degree angle, because right now that's all we're going to work with are 90-degree triangles. So we can find out not only what this side is using Pythagorean, a squared plus b squared equals c squared, but we can find out what this angle is and this angle is using ratios. Now ratios is just another word for a fraction. So if we take the ratio 3 over 4, then that ratio of the side opposite the angle over the side adjacent or next to it could be written as opposite over adjacent. And that is where we come up with a name when we're looking for opposite side over adjacent side. For that relationship or that ratio is called the tangent. And we abbreviate tangent with TAN, tan. So the tangent, or the ratio, in order to find angle A, is based upon the opposite length over the adjacent length, or in this case 3 over 4. So the tangent of A is 0.75. Now when we put these in decimals, we always make 4 decimal places, so if there's only 2, add 2 zeros to it. So that is the ratio. That is the ratio of angle A based on the opposite over adjacent. Now understanding how all this works is not really necessary. You're okay. You don't have to really understand the hows and whys of this. You'll get that later. Alright, so what if we are told that this length here, oops, that's our hypotenuse, isn't it? Let's say that that's 5. Okay, so given that being 5, let's see if I can get rid of some of this stuff here. Let's say that I want to look at the ratio of adjacent over hypotenuse. Adjacent over hypotenuse would be this over this. That would be 4 over 5. That ratio, adjacent over hypotenuse, is right here. And that is called cosine. Cosine of A is adjacent over hypotenuse, which is 4 over 5. So if I say, what is the cosine of A? You would write cosine of A, again 3 letters, equals 4 fifths. Or 4 fifths is 0.8000. Again, 4 decimal places. If I was interested in finding out the ratio of opposite over hypotenuse, that would be 3 over 5, right? And that would be called the sine. Sine has actually got an E on it, but since cosine and tangent are 3 letters, we have our sine 3 letters, and that is called sine. It is not called sin. So the sine of A is going to be the length of the opposite over the hypotenuse, which is 3 fifths, which is 0.6000. Okay? So it's interesting that given this ratio, and then my tangent of A was, what did we say, is opposite over adjacent, which equals 0.7500. Even given three different numbers, if we plug them into our calculator right, we will get how big angle A is. And it will be the same regardless of whether we use 0.75, 0.8, or 0.6. It's kind of a cool little way that this always works. Alright, so you have a key on your calculator. Let's jump to the next slide. That key on your calculator, you have a sine key, a cosine key, and a tangent key. Now it just kind of depends on the calculator what kind of order you have to do it in. Some calculators you push the sine first and then the number. So like the sine of 30 degrees, it will give you a ratio. Now my calculator, when I hit the sine of 30 degrees, I put in 30 and then I hit sine and it gives me 0.5000. And if I push my 30 degrees cosine, that will give me 0.8660. And if I push my tangent 30 and then I push tangent, I get 0.5774. So these are just the ratios. Sine of 30 means if I take the length of the opposite side over the hypotenuse, the side opposite the 30-degree angle, over the hypotenuse, and I divide these, I'm going to get 0.5. Now the cosine is if I take the adjacent one, the one next to it, and divide it by the hypotenuse, I'm going to get that decimal. And in the tangent, if I take the opposite over the adjacent lengths and divide them, I'm going to get that number. Okay? So there really isn't tons to what we're doing here. If you look at example 43.1, they give us a triangle, and they say that this is 4, this is 7, this is 8, and this is 5.74. Okay, the question is, find the sine of A. Sine of A will be, using your SOHCAHTOA, I learned this back in 1974, and I still use SOHCAHTOA to remember this. Sine of A is opposite over hypotenuse. Well, where is the opposite? This is the opposite, that's the hypotenuse. So it's going to be 4 over 7. And when I divide that out, it's going to give me 0.57 for an answer. Okay, so let's say that I want to find the cosine. And I've got a triangle. This particular triangle looks like this, where that's B, that's 8.6, that's 5, and that's 7. So the cosine of B, using my CA, it's going to be adjacent over hypotenuse, and my adjacent to B would be the one next to it that's not the hypotenuse. And then the one on the bottom would be the hypotenuse. So I get that, which is 0.81. And then lastly, I have a triangle. Let's do this in blue. And I've got C, and that's 10, and that's 6, and that's 8. And I'm interested in the tangent of C. Tangent of C is going to be the opposite line over the adjacent line. Remember, don't accidentally put the hypotenuse there. It's the adjacent one. It's the shorter of the two. And we divide that out, and we get 0.75. So there's my three answers that it was asking for. It was to say find the sine, find the cosine, and find the tangent. Okay, and that's it for that section. And let's look at one more piece of this puzzle on this next slide. And this last section is called inverse functions. Alright, so you have a key on your calculator that looks like this, and it will say sine, and then up above it it will say sine -1. And then you'll have a cosine, and a cosine -1, and a tangent. Sorry, I'm kind of being redundant here and writing all this on here. Okay. So if you want the ratio, you push those buttons. So, for instance, if I know the angle is a 30-degree angle, and I'm interested in the sine of the 30-degree angle, I would push 30 degrees and then the sine key, and that would give me a number. Okay? Well, what if I did not know what this angle was? What if all I knew was that I had a ratio of 3/5? Okay, I didn't know the angle. What I would do then is I would take 3 divided by 5 and get 0.6, and then I would push this button, which means my shift key. I would push shift sign, and that would give me 37 degrees. So you use this button if you don't know the angle and you're looking for the angle. You use this button if you know the ratio, like right here, or I'm sorry, if you know the angle and you want to know the ratio. So the sine of 30, you're going to push 30 and just sine, and it will give you a decimal. It will always give you a decimal between 0 and 1. It will not give you a number bigger than 1. If it does, then you push the wrong button or something. So it gives me 0.5. So that's the ratio, 0.5, or 1 to 2. That's another way of writing that fraction. Or opposite over hypotenuse. So if I've got a triangle here, that tells me my opposite length here is 1, and this is 2, and this is a 30-degree angle, because I've got opposite over hypotenuse, 1 over 2. Alright, so if I'm given an angle, I just push sine, it gives me a decimal. If I'm not given an angle and I want to know the angle, then I push the sine -1, and that will give me the angle. Alright, so let's see what else we can do here. In the practice problems, it kind of gives you a little bit tricky one without really going over any of them. It says, what is 4 cosine of 75.8? So what you're going to do for that is you're going to go 75.8 cosine, and that's going to give you 0.1942. And then you're going to multiply that by 4. And you're going to get 0.7769 for an answer. Okay, so all you're doing with that 4 is multiplying it by the cosine of 75.8. Same with the sine. C, D, E, and F shouldn't give you any trouble. We're skipping the story problems and going right to number 7 and continuing on with some trig stuff. And then the rest of it's just the same old stuff that you've done before. So it shouldn't give you much trouble at all for lesson 43.